Ade sir, please start because the participant will join. Please start from your end.
Good morning, all of you.
Good morning.
In second session of this today's schedule, we have a resource person, Sunil Kumar Sood sir. In this session, he will talk on energy conservation in HVAC system. I welcome him on behalf of Sharad Institute of Technology, College of Engineering to this 1 week STTP on energy conservation and audit. I introduce him before start of this session. He is a mechanical engineering graduate from MANIT Bhopal. He has 43 years of experience in HVAC, air pollution control and energy management. He is a founder member of and former president of Indian Association of Energy Management Professionals. He is a certified energy auditor and member of ASHRAE, highly passionate and committed to the energy conservation and efficiency and sustainability. He has taken several steps to promote these concepts. He is presently working as a director of LCG Energy Consultants Private Limited, Bhopal. With this brief introduction, I request Sood sir to start his session. Thank you, sir.
Thank you, Dr. Sanjay Kote, for the nice introduction, and thank you for inviting me to share my experiences in air conditioning systems design. Am I audible? Hello?
Yes, sir. Very much. No issue, sir. Everything
Yeah.
is fine. Please proceed.
So my today's presentation is on energy conservation in HVAC systems. It is a general title, but I will be covering mostly about the air conditioning systems because HVAC involves ventilation also, and ventilation is in itself is a big area. Ventilation of premises as well as including the dust extraction system and all that. So today's talk is confined to air conditioning systems.
Press enter now. You did it actually. Earlier you did it. Yeah. Earlier you did it, so it was okay. Now it's okay. Please.
So when we are talking of energy conservation, better we clear our concept about the energy pyramid, which I often quote because many times it is not very well understood what is the conservation, what is efficiency and all that. So here for our purposes, we will be talking of in fact generally about energy management, which comprises of all conservation, efficiency and renewable energy. Conservation means it is more related to behavioral changes or smart uses, intelligent uses, where actually you are not replacing anything, you are not buying any new item, but with the existing system in place, how best you can use them so that you use less energy. It involves applying certain techniques and understanding of those techniques, how we can reduce by doing that. I will give examples later on. Then next comes energy efficiency. Energy efficiency is more about retrofitting, changing from energy inefficient to energy efficient items and all that. And it involves expenditure, replacement, time. Unlike conservation, which is entirely in our hand, efficiency requires weather availability and all that. Then comes next renewable energy. So we can also save energy by replacing the existing system which is on present fossil fuel based to renewable energy based. So this pyramid depicts that how can we reduce our consumption. At the bottom, say we are having such wide pyramid. See here, you can see the width here. It is so wide because this is a business as usual requirement. You are not doing anything, then your consumption will be this much wide. But if you apply conservation techniques, you can bring it down to this much. And if you also do energy efficiency replacement, then you are bring down to this much. And remaining you can make do with renewable energy. That is the theoretical possible pyramid. So once we have that understanding of energy pyramid, we can then try to understand what is air conditioning, so that then both we can link together. So first, for energy management, we must understand what are the basic principles, because there are certain basic principles. If we understand those principles, we can then apply those principles in any system, whether it is air conditioning system or any other system. So, and first we must understand what energy management involves. Unlike a common understanding that focuses only on the quantity of energy required, actually energy management also involves the quality of energy. Means it is not only about reducing your quantity, but replacing it with maybe better appropriate quality, neither better nor worse than needed. So energy management is actually involving both quantity and quality of energy. So these basic principles, how these are applied for air conditioning, I will be taking up. And these have been depicted again in the form of a pyramid. Yeah. So this pyramid you can see, which I showed you on the first slide. Basically, again, as we have written, business as usual. If you are not doing anything, your requirement is this much big at the bottom. You are at the bottom. Then you are applying these principles. These principles are listed out here: review of historical energy use, improvement of housekeeping and maintenance, analysis of energy use, energy containment, aggregation of energy use, cascade of energy use, regulatory measures. These come under conservation, because here actually you are not replacing or retrofitting or spending any money, just applying your mind, your ideas, your intelligent ways, techniques to save energy. But still you can bring it down to this much, where you are reducing further. What are those? Energy efficiency, more energy efficient equipment, material, you can have better efficient process. You may have energy storage, energy conversion, instead of one form of energy, another form of energy, material economy, substitution of materials, material quality. These all are also important, because we talk of embodied energy also, what has gone into its manufacturing. So these principles come into picture there. Later on, we can always have totally dependent on solar or any other form of renewable energy. So this way, if we approach, so firstly, we should understand firstly basics of air conditioning system, its components, its work, their working, all that, and even including design. So when all these things we keep in mind, then we can apply these principles on air conditioning system, or how we can save the energy. Let's start with the definition. What is air conditioning? Air conditioning now often is taken as if just to maintain temperature. Mostly people are talking of only temperature, but actual definition of air conditioning is it is a simultaneous control of air purity and filtration. Purity means maintaining the CO2 level, oxygen level and all that. And filtration means particle size. So that is done with filters. Air movement means how much draft you are getting at the user end. How much draft. If it is more, then also it puts you uncomfortable. Now again, before that, of course, we all know that air conditioning is mainly for comfort as well as for process purposes. So when it is for process purposes, the approach is different. When it is for comfort condition, then approach is different. So air movement may be more if the process requires. Then dry bulb temperature we have to maintain within the comfort zone. Then relative humidity also, there are studies now available that how the combination of relative humidity and dry bulb actually can save energy. So by appropriately setting as per those conditions, we can save energy. Noise and vibration is also included, because if the air conditioning creating noise or vibration, again it is putting into a different form of uncomfort. So noise and vibration also included. Then of course energy efficiency. In the original air conditioning thing, no one was talking of energy efficiency. Now even National Building Code 2016, or even before that 2000, sorry, so then energy efficiency also included, and then fire safety. This is another important thing covered in the definition, because if there is no fire safety, again there are problems going to happen. This chart depicts the types of air conditioning systems. Basically, mostly vapor compression systems are only mostly used, but vapor absorption systems mainly wherever there is a waste heat, iron steel plant and all that. That there they put vapor absorption systems. Again, these are divided into unitary systems and centralized systems. Unitary systems, again, mostly unitary systems are all DX system in direct expansion or dry clean, where only refrigerant is directly used for evaporators. And centralized system may have both the types, direct expansion as well as chilled water system. For smaller plants, we can have direct expansion, and where we large systems, we need more or due to certain reasons where you cannot have the system, they go for a chilled water system, where refrigerant system produces the chilled water, and the chilled water is circulated through the air handling units or a small fan coil units. So one part is producing the fluid which will cool the air or which will condition the air. Another part is then supplying that chilled cool air into the premises. So it is a vast field, whereby firstly you must start with the heat load calculation. How much is the heat load? And first, before that, you must know what are the conditions to be maintained and what are the other loads: solar load, equipment load, then occupancy load. All these things are done in heat load calculations. Softwares are available. Manually also, people like me, I do mostly manually. So manually, we can then finalize that tonnage required. We can finalize the air handling units, air capacity, humidified air capacity. We can finalize pipe sizing. We can finalize other things, basic. Then later on, when we go for equipment selection, then according to the TR and other things, equipment are selected. So what is the basic mantra for saving energy in air conditioning system? It is just like even for lighting, we say, light, provide light where it is needed, when it is needed, how much is needed, of what quality is needed, and then using most energy and resource efficient system operating on cleanest possible energy. If we apply this basic mantra for a new plant, for a new air conditioning system, we will come out with a very economically as well as uh, energy wise system. Most energy efficient system you will, as a whole, you will be designing when you consider properly like this. Then next, these 5 T's of eco means energy conservation. These are also, I think, known to all. We want to save energy, just turn it off. 5 T's of eco. Just turn it off when it's not needed. You are saving energy. Turn it down means if I am able to do with less temperature, with higher temperature, then I will adjust the thermostat. Tune it up. Sometimes system is not properly tuned, so it causes wastage of energy. So you need to tune it up. Turn it around means trying different options where I can do this way. Clear it out again, checking it out other options. So the first principle for energy management, when we do energy audit also, is the review of historical energy use. We collect data, we then analyze, and we conduct interviews with the operating and the maintaining staff and the officials. At that time, if we ask, why are you doing this? And if the answer is, that is the way, sir, that is how we are doing, we have been doing it always, it means there is a chance to save energy. If things are going on as they have been going on since long, it means new thoughts have not been given. So you can think, there may be chance. Then further when you study, you identify. So by just reviewing of historical, how you have been using the system, asking those questions in a proper way, you get the answers. And then you identify the potential energy saving ideas. Once you identify, say, 10 potential energy saving ideas, you can narrow down to the most viable, or in terms of this one, low cost, no cost, or medium cost, medium term, high cost, high term. That way we can classify. Then I will give an example of case study of chilled water plant versus cooling towers. This is one project which I did when I was in Mekong. The client told us that they want a chilled water plant, and I asked, I went into the details, what is the requirement. So first they were telling 20, I want chilled water at 20 degrees centigrade. Then I further elaborated why 20 degrees also required, whether maybe little more temperature will do. When the client further checked with the scientist, actually it was a scientific establishment, scientist establishment, they have been doing certain things the way they have been doing. So then after further inquiries, they confirmed, sir, actually even you can go as much as 28, 29. Then I told, 28, 29, most of the time I can provide you the same water with cooling towers only. They were first resisting, no, we want only chilled water plant. Then again further all this checking, it was agreed by them also, yes, only for a few hours in a year, wet bulb temperature is higher, and at that time we can manage during those hours, and then remaining time we are anyway getting chilled water, water from cooling tower up to 25, 26 degrees. Then they agreed. So here we saved not only the initial cost of going for chilled water plant, but also running costs, because cooling tower requires much lesser energy. And also we saved space, so we save civil cost also. So these type of questions when we ask even during design stage helps in designing the best system. A case study of home refrigerator which happened with one of my relatives. His bill was coming quite high. He was alone in Mumbai. I asked him why your bill is so high. You're not at home in the room most of the time. Still your bill is 800 rupees per month. Then he was not actually borrowing much, but I insisted that let me see. Then I checked his refrigerator. Actually, thermostat was not functioning. It was always on. It was not working. Then I had that time with me one meter. I put that meter connected with him. I showed him that it's almost 24 hours it is on, except maybe during some power. Then I calculated out of 800 rupees, actual about 600, 500, 600 rupees bill was because of the for the refrigerator, and that is because thermostat was not working. It had set at some temperature which was producing even more cooling and icing everything. So he was undergoing two losses. Food also was getting wasted, as well as he was wasting energy. Now this also again no without spending any money, he came out with this suggestion because of his historical use. Another case study is of Vizag Hotel, with a 5-star hotel. They had two air conditioning systems, one with 125 kilowatt motor. One compressor was having 125 kilowatt motor. Another compressor, both were 60 TR, but they have put 125 kilowatt motor. Another was with same compressor 60 TR, similar compressor, but 100 kilowatt. Then when we checked separately, if I operate this, what is the energy consumption, and if I operate the other one, what is it? These people were thinking that 100 kilowatt motor will be consuming less, so they were more using that 100 kilowatt compressor. The other, and they were using the other one. One was taking one standby. So when I checked, I saw actually 125 kilowatt motor which was connected compressor, that was actually consuming less. It was consuming 59 kilowatt, and the other one was consuming 68 kilowatt. So there was a 9 kilowatt difference, though connected motor was bigger because of the inefficient compressor. Actually, the compressor which was connected with the 100 kilowatt motor was having some problem. It was not. It was earlier gone for some maintenance, and it was not done properly, and they had never checked. But it was running, but consuming. There were more leakages, losses. So then, when we discovered this, then they started running the other one more. Then case study of BSNL Bhopal. This was one BSNL this tower, BSNL office where this they have this all this IT equipment and all that. Then they had different type of systems. As and when some executive engineer decided, okay, let me go for a package unit. Another fellow purchase, let me go for DX system. Another purchase, let me go for chilled water system. And in addition, they had this so window AC and split ACs. So there was no proper check here how much TR actually required, and how much system where what is supplying. Then what we did the overall heat load calculation for the whole building, and then came to know the total TR required, but how much TR actually was put in operation. There was huge gap. Then what we suggested that you stop using DX system and put that AHU which is connected with DX, replace that coil, that instead of DX coil you put chilled water coil there, and there was a scope in the chilled water plant for applying more chilled water. Then I proved that if you make this change, instead of DX coil put the chilled water coil, then you can use the existing chilled water plant or this also, and you can stop using the DX system. That was a very well accepted, received, and everyone thought, oh, we never thought like that. But whether technically it is possible to replace the coil, then we checked with the supplier BSNL and all that. They told yes, we can, as per there is a coil selection criteria for the sensibility factor type. So where we can select the coil as per the required sensibility factor. It was agreed, and later on they changed also. So these type of things are identified when we review the historical energy use or proposed. The first example was the proposed. Then comes to the second principle, improvement of housekeeping and maintenance. We all know that if the plant is not properly maintained, if the housekeeping is poor, how much it affects the energy consumption. During audits, you can identify this. When you are going through the plant, you can check filters. How, and ask also check the regards. How frequently the filters are cleaned, how frequently coils are cleaned. Duct cleaning is not sometimes so easily to check, but if possible, you can check that also. Then functioning of controls. If the controls are not functioning or malfunctioning, are the sensors giving the right signals? These are all part of the housekeeping and maintenance. Many places we have seen clogged filters. Now air quantity will get reduced. More, if the filter is not clean, it will have more resistance. It means the fan will deliver less quantity. When the less quantity is delivered, it means less tonnage.
त्यो त्यो डांगे अन्ना सर तो त्याचं पाहुणा
So it may look very small thing, taking a filter. Even household filters, many times we see they are not cleaned. Coil cleaning is little difficult to check, but you can insist and ask for the records. Controls also, most you should try to check controls, especially thermostat and compressor. Some control we can check by trial, by resetting whether it's tripping or not. So we can do that, and even try to identify the best setting. So you can say that why not you adjust this control this much? Why you have this setting? An experienced air conditioning engineer can actually suggest those things. Next principle is analysis of energy use. Now, when we are doing, when we are having planning or already having air conditioning system or plan, this is more actually for planning stage. But during already existing system also we can apply. Like I said before, effect of change in parameters. What will happen? Now this is mainly for process. Many times during this design stage, process parameters are fixed actually on many assumptions. But when we are now running the plant, when we know that this is for what, then we should try and change, see that whether if I change the temperature setting to this, or if I have this much air instead of this much air, or if I have this much water or this much, then what is going to happen? Of course, first you have to cross check with the process people and all that, but in case yes, we can do that, like it happened in the case of chilled water plant versus cooling tower. Identify that. Once you are sure, no, I shouldn't touch this, then you need not to. But you must at least attempt what will happen if I change the parameters. Then alternative, why we need only refrigeration based air conditioning? Can I have natural cooling? Can I go with alternative like evaporative cooling, or maybe for something free cooling possible? So you must elaborate, must explore that idea instead of directly agreeing to what is given or provided or offered. You must see at least whether partly or whether in conjunction with, or whether I can incorporate free cooling. Most of the places, free cooling is not incorporated because it is a cumbersome process. It is a botheration. So they tell, well, forget it, yeah. But then if you apply that idea where you can do free cooling during the colder nights or during low load, where the temperature, outside temperature is actually good enough for inside conditions, to maintain inside conditions. But for that, you have to provide in HU separate, you have to provide a bypass system where you can bypass the plant and run just HU, no need to run the chilled water plant. You have to provide 100% fresh air system then. Because it is a free cooling system, so your full air requirement has to pass through that. In that case, you have to ensure that filters are capable of taking that load. Because 100% fresh air, then you have to provide separate filter bank, you have to provide separate ducting and all that. But it is still worth it because you are using for 1000 or maybe 1000 or 500 hours free cooling without using the plant. Those ideas we have applied in a few cases where the client was very open to new ideas. Case study of walk-in cold storage. This one, what happened? This was my friend's cold storage. So here he told me whether can you identify anything to save energy. His electricity bill was coming quite high. Again, then I checked the thermostat setting, and also one thing I observed that when the compressor was tripping, inside there was a fan for circulation of air. Inside that fan was continuing to run. Then seeing the length and total volume, I didn't see any reason why fan should continue to run. the normal convection current was enough for circulating for keeping the air in circulation. So this fan is provided for circulation of air. For his application, actually, it was not required. So I told him, when this fan is running, it is not only consuming electricity in its own operation, but also adding heat inside. He didn't know how heat is added inside. I told him the fan, everything is inside. That motor is consuming electricity. Everything gets converted into heat. So when he realized, then I told him, now let me do two experiments. One in this condition, and one when we stop the fan. So the running time reduced by 40%, because that's what was happening. That it was adding to the heat, and quickly again compressor was switching on. So this way we can also cross check the real need, and maybe it may harm the purpose, in fact. So you are doing double purpose. You are saving energy as well as avoiding potential losses. Next idea which we can apply in air conditioning energy principle is energy containment. Containment means where you are not allowing it to go out, either heat or cooling. So you might have seen many air conditioning premises, a lot of infiltration of hot air happens. Hot air outside comes in through many, some we cannot avoid like those, but there are many openings. I have seen in some places where through the cable tunnels, through the cable channel, through some pipe opening, through some other left open of maintenance, hot air ingress happens. Now that adds to the heat and also adds to the dust load. So during the walkthrough, we must notice where this is happening either, and the reverse may also happen where cold air, chilled air may be going out, may be leaking. So you have to contain. You have to see that it doesn't come in, unnecessary thing doesn't come in, or something which we need doesn't go out. Another thing is waste heat recovery. That is also part of energy containment principle. You can try to recover heat for some other purpose. Waste heat recovery of even condenser water is possible. Condenser water outlet is used sometimes for reheating coils to maintain relative humidities. So instead of putting electrical heater, you can put a hot water coil there, and that water actually can be the water from condenser outlet. That will be hotter, and in fact that will help in cooling the inlet water. So you are getting double benefit. You are not only using that heat for maintaining RH, but also reducing the condenser water temperature. And once you have the lesser condenser water temperature, then your PR, your tonnage increases. Aggregation of energy use is another principle which we can apply in air conditioning. So this applies where so many times plants are located a little far away, and all the way chilled water and things are run towards AHUs. So you are not only incurring more cost, but also more running cost, and more maintenance problem. Many times it happens due to the paucity of space. Sometimes designer won't allow, no, I don't want this plant here, noise will come. So they locate the plant little far. But AHUs have to be necessarily, of course, used near the user area. But many times even AHUs are sometimes located little at a distance to avoid noise. But noise is not an issue because you can always have acoustic insulation and almost nil noise level. Whatever noise comes actually because of the air movement and all that. So here as a last check, you can see where I can identify where AHUs can be near the end use areas. Or sometimes another thing which I've seen in one hotel, that was the planning was done by Blue Star, and they had put return grills and return ducting. So there was a supply air ducting and there was a return air ducting. And that return air ducting had to be taken to the air unit. I happened to be there just for some other work, and the person was known to me. I just went through. Then I told him why Blue Star has put the return grills and the ducting and all that. I showed him that how we can actually, because it was occupying certain areas and he was finding it difficulty. So I told him that you need not have this. You can take the return air directly to HU without having the return air grill and return air duct. Of course, there will be interconnecting duct there, but it not elaborate like that. And another thing I told him, if you have both return air duct also, then static pressure for the fan will be increased, and you will have to put another fan to take the return air back. It means you are incurring more cost, because I was confident that the return air may not flow directly to the HU without the return air fan. When this all they checked with Blue Star, they also confirmed yes, it's possible and we can avoid ducting. So what it is an aggregation of energy. Then I told we'll use like this, where no need for separate ducting. Cascade of energy use means using temperature generated by one step of the process to provide preheating needed by another step. This is cascade. Many times we can do that where we need to preheat. This is not much applicable in air conditioning, but I have done this indirectly that there was exhaust air, cool air available which are going anyway out. That exhaust air could be used for panel room, for electrical panel control room, because there is not much occupancy. So partly we use that. Those kind of thing we can see how I can use the waste of one or something useful of one to do the work of another one. That is called cascade. Regulatory measures, of course, we know if we have that kind of regulatory measures, like in Japan, they have budgeting, and they insist that you must do this. So then the consumers plan accordingly. They know that we are not going to consume more than this. That's all. So once they give the target, their maximum consumption fixed at this. So they then try to bring it down. Now BE also has given one sort of regulatory measure that thermostat for air conditioners has to be set, default setting has to be 24 degrees centigrade, so that no one can set the thermostat lower than 24 degrees centigrade. So these are all regulatory measures where the regulatory body like BE can enforce with such measures. Once they see that people are not changing their behavior, they must come out with such regulatory measures which everyone has to follow. Then only discipline also comes. Otherwise, everyone will, where is the regulation? Who told you that I should do this? And even manufacturers won't bother them. Now manufacturers must comply that there is a regulatory system and we have to set the default setting 24 degree. Lower than that is not possible. This is also part of energy management principles. Then more efficient equipment. Of course, this is all well known. Everyone knows that change this to this, change motor, change fan, change pump, all that. But we should be cautious here. Again, we should not see only the equipment efficiency. We have to see the system efficiency. We should not be happy I replace this fan with this energy efficient fan, because we still don't know that energy efficient fan may be still operating it in an inefficient way, because the connected ducting, connected other things are not properly designed. So unless we see the whole system, changing only particular equipment may not help. Once you address the overall system design, then you can later on say confidently that yes, this whole water pumping system otherwise is, say, pipe sizing is correct, routing is correct, and other connected things are correct. Start with the user end. Where is that is being used? So starting from the user end, come back and then check, yes, whole system is as per the need, as per the design, optimum design, and then I am seeing the pump is not efficient one. So I am recommending change of the pump. Otherwise, just changing pump may still not give you the energy conservation. Same way, blindly giving some motor, replacing energy efficient motors actually without seeing the connected equipment may not result in energy saving. More efficient processor. This is another system, another principle. Innovations in design. This, of course, is open to the designers because it is good. It is very easy to be a conditioning engineer, but very difficult to be a good air conditioning engineer. So a good air conditioning engineer will do many innovations, right from fixing the TR, fixing the equipment, sizing, selection, then routing, pipe routing, then duct routing, all that. These innovations are possible when we have complete picture in mind. We are not working in silos. We are not seeing only the narrowed vision, but overall, then we can innovate. Energy storage, of course, is there where you are having a thermal energy storage. This helps in reducing the installed capacity of AC plant. What we can do is, because especially where the load in daytime is more than the night time. So instead of going for a bigger plant to cater to the full load, you can go for a say 60-70% capacity plant and run the same plant in the night and have either ice or electric salt based thermal energy storage, which will then later on next day will provide you the remaining 30% for that period only where peak load is there. So what you are doing, you are reducing the installed capacity, means you are reducing the initial cost. Of course, then you are incurring extra cost for thermal energy storage, but overall it will be less than the full AC plant cost. Plus, then you are reducing the energy cost. So wherever possible, we should try to utilize the low capacity need, and then bring down the initial plant tonnage. Energy conversion. Sometimes we may need, instead of electrical energy, means higher quality energy. Electricity is the highest quality energy. We all know that. So wherever it is possible to reduce, to instead of electricity, if we can use other form of energy, then we are saving energy. An example is here, condenser water heating, hot water condenser water heating. We also know that wherever required, we can use direct solar thermal also. So it's a low quality energy but free. So we can, wherever you can replace electrical energy with another form of energy. But there is an example of reverse also, where pneumatic, wherever a compressed gas is being used, if you can use electricity there, then also you are actually saving energy, because you are using you are avoiding use of compressed air, which actually requires much more energy. So these are type of ideas you should try to apply. Material economy. Now this is related to more about the manufacturing stage, where if we go to that level where now many industries are going, greening of the supply chain. So greening of the supply chain also comes under this, where we can insist that whatever you are supplying, it should have some salvage value or some reusable parts, and structure you should design for reuse and relocation. This type of condition we can put during the preparation of the specifications. And sizing and routing is also another thing, where actually during sizing and routing of pipes, ducts, we can try to minimize the material use. We can identify that how can I, because many places they route or they size without actually giving any consideration for the material use. So when you are giving that consideration, you start thinking, how can I save on material in the design, in the initial manufacturing stage itself. Substitution of materials. So wherever possible, can I use lower quality material? Can I use a material which requires lesser, which causes less emission during its manufacture, which has longer life, or which is easier to machine? All these ideas are possible if we keep those things in mind. We can ask the manufacturer what material it is. Of course we ask, but we don't apply those things, where we should insist that I want ducting of this material, or I want piping of this material. We should be up to date where we need to be up to date, because many times we are not up to date about the materials available. So if you are ahead of time and you know this material is available for this now, why not I prescribe it? Why not I suggest that you put this material? Then of course we know that now instead of going for so much, we can, after that we can go for solar system or any other renewable energy system. So this is as per the pyramid, energy pyramid, where first you are doing conservation, efficiency, then solar. Because when instead of directly jumping to solar, whereby then you have to go for a bigger solar plant. If you apply all conservation techniques and then incorporate efficiency, then your requirement comes down. Your need for the system will be reduced. Instead of say 60 TR, you may need only 30 TR. Then 30 TR solar system will be much cheaper. But if you are doing any consideration for conservation efficiency, directly jumping to solar, or I will put solar, then your sizing will be bigger. Your solar system will be bigger, everything. That is what unfortunately happening without addressing the conservation and efficiency issue. Directly, many people are simply buying solar. They waste energy in all ways. They don't have energy efficient fan or light, this and that, but they have solar power plant in the roof. Energy audit, design audit recommendations. This is one another thing which I told also. If you do design audit and best practices, you must have the list of the best practices and apply those best practices in your case, and do the design audit if it is already a existing plant, because during the designer doesn't know many things, even the end users don't know. So end users and the designers, they somehow come to some conclusion, okay, we'll put this. It is of course the job of the designer to ensure that even though there is any oversizing or undersizing, it should work efficiently in all conditions. Even if I have done design in the initial phase, but when it is under operation, it should have the flexibility to be operated at any level efficiently. So those things we can do during design audit and energy audit. Now at the end, actually, because my inclination towards the sustainability, I've been always trying to connect whatever I do with sustainability. So I was just going through that 5 elements. So because we are talking of air, so air is one of the basic 5 elements based on which whole cosmic creation is actually working, Panchabhutas. So how best we can connect our profession of air conditioning, energy audit, whatever, how can we best connect with the 5 elements, so that actually then our design, our use, everything is aligned with the cosmic creation. This thought is there in my mind. I am passing it on to all. Maybe some of the participants would be able to contribute more ideas on this, how to take it forward, because these 5 elements actually are linked with our 5 senses also. And air is linked with our sense of touch. And that is why it is directly related, because we feel touch. So when I am planning or designing or using air conditioning system, how can I pay respect to that air which is giving me life, which has oxygen in it, which also has some water vapors, which is also now creating problems in the form of COVID or this and that. So now my air, which I am trying to condition, actually even the use of word conditioning means I am trying to condition something which is created by the God. So when I link this, my profession technically, with this spirituality, probably I will have my mindset will be better, I think. So this is just, I'm giving a food for thought for all of you. And with this, I will end my presentation. I don't have much to now present, but I am willing to take questions.
Any question from participants?
So is there any question? I think there are some questions in the chat.
You can put your questions in chat box or you can ask directly by unmuting yourself.
So if there are no questions, then you can end, Dr. Kut.
If there is any question, you can also put on the WhatsApp group. We can directly forward to the Sud
Yes,
sir.
sure. Yes, please.
Sir, can you please just tell the basic about this free cooling, sir? You were discussing about this free cooling, right? Can you please tell about it?
Yeah, yeah. Free cooling, what we say is to use the outside ambient air condition to our advantage. Most often, not most often, of course, many times about 1000 to 1500, sometimes more, depending on the location. Outside ambient air is actually colder than the inside. So there you are using the direct outdoor air, outside air directly. This is one way, or you can use condensed water. Means instead of producing chilled water, condensed water itself is available at 15 degree, 12 degree centigrade. So why not use directly condensed water in the part? There, of course, we have to be very careful and see that condensed water is doesn't spoil the cooling coil. For that, you have to provide necessary filters and all this. But just then run cooling tower, produce the water required for the inside, and then you can avoid running the chilled water plant. This is free cooling. Or alternatively, instead of water route, we can have the air route. Means you are directly sucking the colder air out from outside and passing it through the air handling unit. So this is free cooling.
Thank you, sir. Thank you.
But you are avoiding the use of chilled water plant, which is about 90% free cooling. It is.
Okay, sir. Thank you, sir.
Anyone can contribute on that 5 elements. How to link air as a spiritual, some spirituality in our profession.
Sir, didn't get it, sir.
No, I in the last slide you saw 5
Yes, sir.
elements.
Yes, yes.
There is one of the 5 important elements without which there cannot be any life in this planet. So what I am asking is how we can link this concept of 5 elements, especially related to air, and then connect it with our use of air conditioning, design of air conditioning, all that. Okay, this I am giving you food for thought for later, and you can share it on WhatsApp. I am doing a study on this.
Okay.
And how actually we can reduce our need itself then. See, the biggest, the easiest way is what? To reduce the need of air conditioning. Here, the air conditioning supplier may not like me because their business will come down. Actually, air conditioning suppliers and air conditioning energy auditor don't go together because they reduce the need or they bring down the use, then their business gets affected. So that is one sort of problem in our energy audit profession, where we are encouraging either no need or less need, then their business gets affected. Like the first example where chilled water plant was required, the supplier were looking for some tender. Okay, there will be a tender, but when we gave no, let us go for cooling tower, then their potential business will be reduced. So in case of sustainability dimension, where we want to also see that government especially wants GDP growth. So GDP will grow only when products are sold, services are sold. If products and services are not sold, GDP will not grow because they are not adding other things in the GDP. They are adding only what is in terms of rupees. If I am not using only, it means I am not buying, means then I am not adding to the GDP. So here, of course, we have to keep balance, but present balance is too much tilted towards the buying more products, more services. But when we link it with this 5 elements, Panchabhutas, then we know that we learn to live with these 5 elements. And when we do that balancing our own, because our 5 senses are governed by this. Our 5 senses of sense to hear, sense to touch, sense to taste, sense to smell, sense to hear, all these are linked with these 5 senses. It means our need is again then linked with this, because our senses are then as per what we perceive. So when we take this any profession to that level, then you do the best. This is what I wanted to say. Air is something without which we can't live for more than 1 or 2 minutes. But we give the least importance. Okay, then I will end the session now. There are no
Yes,
further questions.
yes, sir. Is there any question? Please ask. Okay, sir. Just I propose a vote of thanks. I thank Sud sir for a nice session on this HVAC system. He discussed
Thank you.
about more efficient processes, equipments, regulatory measures towards this energy conservation. He also discussed some case studies of commercial building and government building. Once again, I thank Sud sir for sharing his experience to our participants.
Thank
Thank
you
you,
very
sir.
much.
Thank you. Thank you, sir.